In this video, we are going to be solving equations that contain rational expressions. Now, the way that we're going to do this is we're going to think about these rational expressions like we would with fractions. Whenever we're adding and subtracting fractions, we need a common denominator. So our first step is to find the LCD of all the rational expressions and then make them all common. So, looking at 3x, 6, and x, I need to determine the least common denominator of those three denominators. Looking at the coefficients, meaning the 3 and the 6, we want the least common multiple of 3 and 6. Well, 3 goes into 6, and 6 divides into itself, so 6 is the least common multiple, right? Multiples mean 6 times 1, 6 times 2, so on and so forth. So 6 times 1 would give us 6, and 3 times 2 would give us 6. Hence, that is the least, it's the smallest common multiple of those two numbers. We also have to consider the variables. In this case, there's an x, and there's only one x in each denominator here. So x is going to be part of our LCD. Once we've identified the least common denominator, we need to make all the denominators look like that LCD. Here we have 3x. So to make 3x into 6x, I would need to multiply by 2. Whatever I do in the denominator, I have to do the same thing in the numerator because it's like I'm multiplying by 1, right? 2 over 2 is 1. So to keep this equivalent, I have to multiply the denominator and the numerator by 2. Now this denominator would be 6x. The middle denominator here already has the 6. It doesn't have the x. So I would multiply this middle fraction by x. But whatever I do in the denominator, same thing in the numerator. The last expression here, I have the x, but I don't have the 6. So I'm going to multiply by 6 in the denominator and 6 in the numerator to keep it equivalent. I'm going to go ahead and rewrite this real quick as 2 over 6x plus 5x over 6x equals 12 over 6x. All I've done is I've multiplied 2 times 1 to get the 2, 5 times x to get 5x, and 6 times 2 to get the 12. And we see that all the denominators here become 6x. Once all the denominators are the same, I can multiply everything by 6x. So I multiply the left-hand side of our equation by 6x, multiply the right-hand side of the equation by 6x, and it will divide out with all the denominators. So I would distribute here, and the denominators would all divide out. The only thing I would be left with are the numerators. So essentially we are clearing out those fractions. Right? So 6x times 2 over 6x. The 6x's divide out. You're left with 2. 6x times 5x over 6x. Again, the 6x's divide out. You're only left with 5x. Same thing on the right-hand side of the equation. Whatever we do to one side of the equation, same thing to the other side of the equation to keep it equal. And 6x times 12 over 6x. Again, those 6x's divide out, and we only have the 12. So once we have common denominators, we can clear out those denominators by multiplying every term by the LCD. Now we're here, and we're at a linear equation, which is nice to solve. I just need to get x alone. I start by subtracting 2 from both sides. I'd be left with 5x equals 10. And then we divide by 5 to undo that multiplication. and x equals 2. With rational equations, you have to be very careful with the solution that you find because there are restrictions on the domain, right? So you cannot divide by 0. So any solution that when you check it makes the denominator 0, well, that's not part of the domain and therefore not a solution. So let's look at this original equation here and think about what x could not be, what is not in the domain. And the only thing that would make these denominators 0 would be if x equaled 0. So x could not equal 0. Our solution was not 0, so this should work. You should always plug it back in just to confirm. Let's look at another equation. Here we have 3 over y plus 5 equals 3 divided by 3y minus 2. You should always start by factoring if there's anything to factor. I do not see any GCF. This is two terms. It's not a difference of squares or sum or difference of cubes. Not factorable. Same thing here. If they're not factorable, then you know the LCD, if they have nothing in common, is going to be each factor. So y plus 5 is a factor, and 3y minus 2 is a factor of our LCD. Since they had nothing in common, and I have to have both as part of my LCD. Alright, now we need to make each of these rational expressions look like that LCD. So this first one has the y plus 5. It does not have the 3y minus 2. Again, whatever I do in the denominator, the exact same thing in the numerator. On the right-hand side of the equation, I have the 3y minus 2. I don't have the y plus 5. Whatever I do in the denominator, same thing in the numerator. I have to make each denominator look like this LCD. Once both denominators look like that LCD, and I've kept it equivalent by doing the same multiplication in the numerators, I can clear out those denominators, right? We would multiply everything by the LCD. So on the right-hand side, let me grab a different color here. On the right-hand side of the equation, I would multiply by that LCD. And they would divide out, right? I would do the same thing on the right-hand side of the equation, multiply by the LCD. And that's just whatever I do the left-hand side, I do the right-hand side of the equal sign, and then again, those denominators divide out. The only thing we're left with is the numerator. So in the numerator, I had 3y minus 2 times 3 on the left-hand side, and 3 times y plus 5 on the right-hand side. A couple things I could do from here. I could just divide out those 3's, since both sides have a 3, but that's not always going to be the case. So I'm going to go ahead and distribute. To get rid of those parentheses. 3 times 3y is 9y. 3 times negative 2 is negative 6. 3 times y is 3y. And 3 times 5 is 15. Again, now I have a linear equation. No x squareds or rational expressions in here. And I can solve for y. I start by getting my variables on the same side. I subtract 3y from both sides. And now I have 6y minus 6 equals 15. Then I would add 6 to both sides. So 6y equals a positive 21. And then divide by 6. you can simplify that fraction by dividing out a common factor of 3. So divide by 3 to reduce that fraction, and we end up with a positive 7 halves. Again, we want to check our domain of the original equation. So looking at the y plus 5, that means that y could not be negative 5, right? Negative 5 plus 5 would make 0. And looking at the second domain, if you solve that by setting it equal to 0 and solve for y, you would have to add 2 and divide by 3. So y could also not be 2/3. So 7 halves is part of our domain, and you should plug it back in to check to make sure it's equivalent. Alright, we have one more here on the left-hand side. This one has a whole number that is not a fraction. So I want to make sure every term in my equation is a fraction. So I'm going to go ahead and put that 5 over 1. Looking at the denominators, the LCD is going to be a minus 6, right? So 1 has infinitely many multiples. We don't have to take that into consideration when we look at the LCD, because I can multiply 1 by anything and get the other number or expression. So the only thing here is a minus 6. So automatically that is the LCD. This first rational expression has a minus 6 in the denominator already. The last one has a minus 6 in the denominator already. What doesn't is the 5. So a lot of times students forget that whole number. They want to just clear out the rational expressions that are there, but you have to keep it equivalent. So when I multiply every term by the LCD, that means that this one is going to be multiplied as well. So I multiply numerator and denominator by a minus 6. Now all of the denominators are equal. I would multiply everything by the LCD, and that will clear out these denominators, just as we did previously. The only thing that will be left will be the numerators. So 2 minus 5 times a minus 6, that will equal 2a minus 10. Again, we can solve this. I'll start by distributing that negative 5 times a, and negative 5 times negative 6 will be positive 30. I'll gather my like terms. 2 plus 30 is 32. And then get my variables on the same side. I'm going to go ahead and add the 5a, add 5a, and if I move my variable to the right, I will move my constant to the left. So 0, 0. 32 plus 10 is 42. And 2a plus 5a is 7a. Lastly, I'll undo that multiplication with division. 42 divided by 7 is 6. Alright, as I mentioned previously, we need to look at the domain of the original equation. So the only denominator was a minus 6. This means that a cannot be positive 6, because 6 minus 6 would give us 0, and we can't divide by 0. But our solution was a equals 6. So what does that mean? Well, it means that this is not a solution. So there is no solution here, because the only solution we found was not part of our domain. Go ahead and try the examples on the right. Alright, here we are on the right hand side working through these solving rational equations. So looking at the three denominators here, we're going to start by identifying the least common denominator. In this case, the only coefficient is 2, and we see the variable x. There's no pluses and minuses here. It's all going to be the terms 2 times x. Now, we have to make all the denominators look like this. The first denominator is just x, so we have to multiply by 2. Now it's 2x. Anything I do in the denominator, same thing in the numerator. In the next denominator, I have a 2, so I need to add the x. Now again, I have 2x. Once all the denominators are the same, I can clear the denominators by multiplying every single term by the LCD, and the LCD and the denominators would divide out, so they're gone. What I'm left with is 2 times 1 minus 1 times x. That will equal 7. I want to solve that equation. I'm going to subtract 2 from both sides. Then I need to get x totally alone. I divide by -1. This is what I think the solution is. I go back, I check the domain. So the only thing that would make these denominators 0 would be if x equaled 0. So x could not equal 0. We didn't get that solution. We could plug it back in and it should work. Another example. The only denominators are 3 and x minus 2. They have no common factors. So together they make the LCD. 3 times that x minus 2. I need to make both denominators look like that. The first one has the 3. It is lacking the x minus 2. The second denominator has the x minus 2. It doesn't have the 3. So I multiply numerator and denominator by 3. Once the denominators match, I can clear those denominators by multiplying everything by the LCD. What is left is 5 times x minus 2 equals x times 3, or 3x. I would distribute to get rid of those parentheses. Gather my variables on the same side. So I subtract that 5x over to the right hand side. This leaves me with -10 equals -2x. Divide both sides by -2. That means x equals +5. Now, again, check our original domain. The only thing that would make the denominator 0 would be if I put in a 2 for x. So x could not be 2. Our solution was not 2. We should be able to plug it in and have it work. I'll leave the checks up to you. Next example. I left you guys the harder ones. You have to factor completely before you decide what the LCD is. So here in this example, I have x plus 1, I have an x minus 1. Those are different factors. There's no way to make those match. And in the middle, I have a difference of squares. This is x squared minus 1 is the same thing as x plus 1 times x minus 1. Whoops, 1. It's a difference of squares. It factors into conjugates. So we look at this and we see the LCD is exactly that. Those are the only two factors I see. X plus 1, x minus 1. We need to make all of those denominators match. The first denominator has the x plus 1. It does not have x minus 1. So I add that to the numerator and the denominator. The middle rational expression here already has x plus 1, x minus 1. That's what x squared minus 1 factors into. This has both pieces of our LCD. I leave it alone. The last rational expression has the x minus 1. It does not have the x plus 1. So I add that to the numerator and denominator. So now all the numerators and denominators have an x plus 1, x minus 1. This is x plus 1, x minus 1 factored, and x plus 1, x minus 1. Once all the denominators match, they're all common, I would multiply everything by the LCD and clear out those denominators. What I'm left with are the numerators. So 2 times x minus 1 and 1 times x plus 1. 1 times anything is itself, so I just have x plus 1. Again, I see parentheses, I distribute. I gather my like terms on the same side of the equation. Negative 2 plus 5 is a positive 3. Then I move my variables to the same side. If I move my variable to the left, I'm going to move my constant to the right. 2x minus 1x is just x, and 1 plus a negative 3 is negative 2. I check that with my domain. The only values that would make these 0 would be if I plugged in a negative 1, because negative 1 plus 1 would be 0, or a positive 1, because 1 minus 1 would also be 0. So x could not be negative 1 or positive 1. We did not get that solution, so we should be okay. Again, you should always plug these back in and check. You should end up with a true equal statement when you simplify. Last example here. You must factor all 3 parts, or all 3 denominators. Z is factored. There's nothing we can do with that. The right-hand side, I see a GCF of Z. I could factor out a Z. When I divide that out, I would be left with 3Z minus 2. And the first denominator here is a trinomial where the leading coefficient is not 1. So I'm going to do some side work to factor that. Remember, we have to multiply A times C. So I want factors that will multiply to a negative 18 and add to a positive 7. So factors of 18, 1 and 18, 2 and 9. That sounds good. I can get 7 out of that. I would need to add a negative to make it multiply to a negative, but I need it to add to a positive. So I put the negative with the smaller number. Negative 2 times 9 is a negative 18. Negative 2 plus 9 is a positive 7. So now, again, that leading coefficient was not 1. I rewrite my middle terms as negative 2z plus 9z. Now I have 4 terms. I group them, pull out the GCF of each. The first 2 terms, I have a GCF of z. That leaves me with 3z minus 2 when I divide out z. The second 2 terms have a GCF of positive 3. I divide that out. I'm left with 3z minus 2. Don't stop there. Complete it. I now have a common factor of 3z minus 2. I take that out. When I divide that out, I am left with z plus 3. So this factors into 3z minus 2, minus 2 times z plus 3. Alright, now that I have all of my denominators factored, I can identify the LCD, the least common denominator. The LCD here, these are all distinct factors, meaning 3z minus 2 and z plus 3 and z are all different factors. right? I have a 3z minus 2 in common, but I only need one. This only has one factor of 3z minus 2, and this one only has one factor of 3z minus 2. So now, I need to make all of the denominators match. The first two have 3z minus 2 times z plus 3. What it's missing is the z. Oh, sorry, let me write out the LCD. Z times 3z minus 2 times z plus 3. So the first denominator has the 3z minus 2 and z plus 3. It does not have the z. So I multiply numerator and denominator by z. The middle rational expression has the z. It doesn't have the 3z minus 2 or z plus 3. So I multiply by 3z minus 2 and z plus 3 in the numerator. Same thing in the denominator. The last term has a z, has a 3z minus 2. It does not have the z plus 3. I add that to the denominator and the numerator. Now, I have multiplied all of the numerators and denominators by the same amount, and I've made all of the denominators look like the LCD. Z, 3z minus 2, z plus 3. Z, 3z minus 2, z plus 3. Z, 3z minus 2, z plus 3. They all match. Once all the denominators are the same, I would clear out the denominators by multiplying every term by the LCD. Now I look at what's left. I have z times 3z, which is 3z squared. I have a negative 1 times 3z minus 2 times z plus 3, and that will equal 4 times z plus 3. So now I need to simplify this a little. I'm going to bring down the 3z minus 2 and the negative 1, and I already know 3z minus 2 times z plus 3. I don't need to FOIL or do anything with that. I already know what this is when I multiply because I factored it. So what is it when I multiply back? It's 3z squared plus 7z minus 6. So I'll just fill that in. 3z squared plus 7z minus 6 equals, I'm going to distribute that 4z plus 12. I'm going to also distribute the negative 1. Now I have 3z squared minus 3z squared minus 7z plus 6. All of these signs changed. Was positive, now negative 3z. Was positive 7, now it's negative 7. Was negative 6, now it's positive 6. And that will equal the 4z plus 12. I know 3z minus 3z is 0. I want to get all my variables on one side. I'm going to go ahead and add 7z, add 7z. If I move my variable to the right, I'm going to move my constant to the left. And what am I left with? Positive 6 minus 12 is a negative 6. Positive 4z plus 7z is 11z. I divide both sides by 11. And my final answer is z equals negative 6/11. But I stop, I recheck my domain, right? I want to make sure that this solution will not make any of my denominators 0. So looking at the three possible ways to get 0, if z itself was 0, so z could not be 0, And here I'd set this factor equal to 0, 3z minus 2. I would add 2 and divide by 3 to make that 0. So z cannot be 2/3. And then the last factor, z plus 3, z cannot be negative 3, because negative 3 plus 3 again would give me 0. Negative 6/11 is not one of the restrictions on our domain, therefore that is the solution.